Hello again, everybody, and welcome back. This example 8.4 is a good kind of a real life example. What you need to do, what kind of work you need to do, if you can consume a certain amount or type of food. In this case, the food in question is a Snickers bar, and Snickers are known for having lots of energy in them. Now, when we say energy, we mean like chemical energy, wrapped up in things like peanuts and caramel and chocolate and whatever else is in them. Lots of kind of sugar energy in there, and usually you consume something like this before you do some sort of strenuous activity. Well, if you want to eat a Snickers bar, you probably should do some sort of strenuous activity so that your body, we say, burns it off. Well, what that means is your body converts that potential energy in your body to you actually working, whether it's lifting weights or doing something else. In this case, the girl wants to climb stairs. All right, how many stairs does she have to climb to work off the Snickers? So let's just sort of picture this right here. All right, so here is, let's see if I can draw a Snickers bar. All right, Snick. All right, not very well drawn, but that's our Snickers bar right there. And this is our girl. Let's see, just draw her. Again, not all that wonderfully well drawn, but you get the idea. And she looks kind of like a snowman. So it's a female snowman. I don't know. All right, but she consumes that Snickers bar by eating it. All right, that becomes potential energy. So I'm going to draw a big U inside of her. And if she doesn't do anything about that potential energy, what your body does is it converts all that energy to, it stores it, and it converts it to fat. All right, that's why we tend to get fat if we overeat and don't exercise, because our body stores it as chemical energy. It can be used later on, but you need to be, you need to do exercise in order to use that up, to burn that off. So what she wants is to take that potential energy that is inside her body and turn that into, these are stairs right here, and she wants to burn it all off and turn that into gravitational potential energy at the top right there. All right, so she's gone up a certain number of stairs, whatever number of stairs that is right there. She wants all this chemical potential energy from the Snickers to be turned into gravitational potential energy, which means it won't be stored in her body as fat, and she'll be able to maintain her figure. All right, so that's the idea right here. So, first of all, we need to define the gravitational potential energy as being mgh. All right, we have defined that already. Mass times gravity, so it's the force that she has to exert by going up to the top of the stairs, times the height, that distance between the bottom of the stairs and the top. All right, this h right there is really what we're solving for, because we're going to be able to find out how many stairs she actually has to climb in order to do that. But we also need to figure out what the energy is that she has to burn off. The energy that is in the Snickers bar that has to be set equal to mgh. So let's go ahead and solve for that right now. There are a couple of nuances to this. The energy in the Snickers bar right here is going to be 271 calories. Okay, with a C, capital C-A-L. All right. Well, a food calorie is actually what's called a kilocalorie. It's 1,000 calories that we talk about in chemistry or physics. All right. It's 1,000 of what you might call a gram calorie. So 271 calories. Let's convert this to a certain number of joules. All right, joules of energy. One thing I should probably point out that I didn't at the outset is that 1 gram calorie, or 1 calorie that you would use to calculate in chemistry or physics, is going to be 4.184 joules of energy. All right, but we need to convert from kilocalories to gram calories. Well, this capital calories, 1 capital calorie, which is a kilocalorie, is 1,000 of gram calories. All right, which is what I just gave you a conversion for up here. All right, well, let's convert gram calories to joules, and then we'll have a certain number of joules of energy that she has to burn off by going up these stairs. Okay, so 1 lowercase calorie is going to be 4.184 joules of energy, and that'll tell us the amount of potential energy she has to put into her body as a form of gravitational potential energy, so that the chemical potential energy from the food is all burned off and she doesn't gain any weight. Okay? So let's multiply these all together to turn this potential energy in question into something in the form of joules. Okay? And so I get a value of 1.13 times 10 to the 6th joules of energy just in one Snickers bar. All right? Just in one Snickers bar. So we want that to be all consumed by her doing work against gravity, going up those stairs right there. Okay? So let's set that equal. These things are equal. Let's set equal to mgh and solve for h. All right? So the Snickers potential energy of the Snickers is going to be equal to mgh. And so h, our height that she has to go up, is going to be the potential energy in the Snickers divided by mg. All right, so that is our 1.13 times 10 to the 6th joules divided by her mass. What is her mass? It's 50 kilograms, right? 50 kilograms times 9.81, which is our acceleration of gravity. Okay, what do we get in terms of a height that she needs to walk up or climb up vertically in order to burn off all the energy that was previously stored in the Snickers bar? Okay, so when I do my math, I get that height is 2,303 meters. Straight up. All right, that's like half a mile. Straight up. So she has to climb a lot of stairs here. Let's convert that to stairs and see how many stairs she actually has to climb up. 2,303 meters. Okay. Let's convert that to centimeters and then centimeters to stairs, and that'll tell us how many stairs she actually has to climb. All right, so 1 meter is 100 centimeters, and 20 centimeters equals 1 stair. And that's going to give us our value in number of stairs she has to climb to burn all that off. So I'm going to multiply that by 100. Divided by 20. I get, and this is a big number, 518 stairs, or I'm going to say 1.15 times 10 to the 4th stairs, which is a lot. It's really a lot, but a Snickers bar has a lot of energy stored up in it. Now, the good news is that for every time you eat a candy bar, you don't have to climb that many stairs because your body is using that energy for other purposes. All right, it's using it to for your heart to pump and for your brain to continue working and all your various different systems right there. So it's using some of that energy, so you don't have to actively move yourself up all that height to burn it off. You don't need to work all against gravity to burn all that off. Your body's doing other things. In fact, you're even burning calories. You're burning energy while you sleep. But you can accelerate the rate at which you burn calories and therefore decrease the likelihood that you're going to gain weight in the form of fat by doing exercises like this. So this is a large number of stairs right here, but that's assuming that your body isn't doing anything else. In reality, you probably have to climb a little bit less stairs, but all other things being equal, this is the amount of stairs you have to climb. So when you eat a Snickers bar or a high energy bar, it's a lot of energy you're putting into your body, and hopefully you're going to burn it off in one way or another if you're not actually going to climb stairs. Otherwise, that energy is going to be stored in the form of chemical energy in your body, and that usually takes the form of fat. So if you want to avoid that, make sure you stay active. So that's our example 8.4 of how high do you have to climb in order to burn off a Snickers bar, and hope that makes sense. If it doesn't, make sure you come and see me, and I'll be glad to help you. Thanks for following along. I'll see you on the next one.